Welcome to qnawire.
Let F1 be the force acting on a mass 1 and F2 is the force acting on a mass 2. According to Newton's second law, their displacements are given by d1 is 1 over 2a1 t square. That is equal to 1 over 2, writing acceleration in terms of force and mass, that is F1 divided by mass 1 t square, where d2 will be 1 over 2 F2 divided by mass 2 times t square. The corresponding displacement of the center of mass can be then written as dcm m1 d1 plus m2 d2 divided by mass 1 plus mass 2. Substituting in d1 and d2, we get the simplified form of 1 over 2 f1 plus f2 divided by mass 1 plus mass 2 times t square. Part A of the problem, when we have a mass 1 is equal to 2 times 10 to the power minus 3 kg, and a mass 2 of 4 times 10 to the power minus 3 kg, with the forces given F is equal to F1 is minus 4 Newton in I direction plus 5 Newton in J direction, where F2 is the force in 2 Newton in I direction minus 4 Newton in J direction. And the T we have is 2.00 times 10 to the power minus 3 seconds. Then we can write the center of a mass of the displacement will be substituting those values. We already wrote the formula. We'll plug all those values in this formula. And the answer we get here for the center of mass displacement to be, this will be in the vector form, minus 6.67 times 10 to the power minus 4 meter in I direction plus 3.33 times 10 to the power minus 4 meter in J direction. Then the magnitude we can calculate will be simply the square root of minus 6.67 times 10 to the power minus 4 square plus 3.33 times 10 to the power minus 4 square. This is equal to 7.45 times 10 to the power minus 4 meter, in which is equal to 0.745 millimeter. Part B, the angle of a D center of a mass is given by theta, tan inverse of 3.33 times 10 to the power minus 4 divided by minus 6.67 times 10 to the power minus 4. This gives us an angle of 153 degrees, measured counterclockwise from a positive x-axis. Part C, the velocities of the two masses are v1 is equal to a1t, that is equal to f1t divided by mass 1. Similarly, v2 will be f2 times t divided by m2. And the velocity of the center of mass will be using the equation of a center of mass, that is m1 v1 plus m2 v2 divided by m1 plus m2. And plugging the values for v1 and v2, so v1 will come here and v2 will come here. This simplifies into f1 plus f2 vectors divided by m1 plus m2 times t here. The corresponding kinetic energy of the center of mass will be 1 over 2 m1 plus m2 v center of mass square. V center of mass we just found, so we'll square that and multiply with m1 plus m2. Then the kinetic energy of center of mass we get is 1 over 2 mod of f1 plus f2 square divided by m1 plus m2 times this whole times t here, t squared. Then with the values of F1 and F2, which is square root of 5 Newton, so F1 plus F2 mod is a square root of 5 Newton, we get kinetic energy of center of mass to be, substituting those values in above equation that we wrote, we get 1.67 times 10 to the power minus 3 joules. This is the kinetic energy of the center of mass.